This is part 2 of our video on compound interest. In the first part, we took a look at a review of the formula and how we calculate our different interest rates depending on the compounding period. So we're now going to do a couple of examples. So our first one here says, Sebastian invests $500 in an account that earns 2.4% per annum compounded monthly. How much money will he have after 5 years? So when I read the question, I see some important things. I notice the $500, the 2.4% per annum, which means per year. I also notice that it's being compounded monthly, which means we're doing it 12 times a year. And we want to know how much money is he going to have after 5 years. So the first thing I need to do, since we've learned about simple interest and compound interest, is I need to ask myself, is this a simple or a compound interest question? Now, I do notice the word compounded, which tells me that this is a compound interest question. So we're going to use the compound interest formula, which is A equals P times 1 plus I to the power of N. And we are going to list those values down the side of our page. So I have A, P, I, and N. You'll notice that I left a little bit of extra room for the I because I'm probably going to have to do some calculations there. So that $500 is the original amount of money that he's putting in his account. So the original amount of money is the principal, or the P. So my P is going to be $500. Now that 2.4% per annum, that's 2.4% per year, is going to be my interest rate. So I do 2.4, but I notice that it's being compounded monthly, which means we're earning the interest 12 times in a year. So we don't get the full 2.4% every time. What we do is we split it up into 12 equal installments. And then because I can't put it in as a percent, I need to put it in as a decimal, we also divide by 100. So I'm going to try that on my calculator. So 2.4, a little bit of glare there, divided by 12 divided by 100 is 0.002. Okay, we have the 5 years. So N is our 5 years, but it's not being calculated once a year. It's actually being calculated every single month. So while we are doing it for 5 years, we're doing it 12 times a year for 5 years. So what we do here is we take our interest rate, we divided it by 12 to break it up into 12 installments. With our N, we know we're doing it for 5 years, and we're doing it 12 times a year for 5 years. So we actually multiply to do 5 times 12, which is 60. So we're doing 60 months worth of calculations, and this 0.002 is the amount per month. Okay. So we're going to take all of these numbers and substitute them into our formula. So I have A, which I do not know, equals P, which is 500, times 1 plus I, which is 0.002, to the power of N, which is 60. Now, I can do all of this on my calculator exactly as I see it. I could simplify what's in the bracket first. I think I might do that. So A equals 500 times 1.002, that's what I get when I add them together, to the power of 60. And then I'm just going to let the calculator do the work for me here. So 500 times, you can put the bracket in if you like, I think I will. So bracket 1.002, you could have done 1 plus 0.002, close the bracket, to the power of 60. And I end up with 563.680871. Now this is money. Money, we always keep 2 numbers after the decimal place. So I have 6 and 8, and the next number is a 0. So that means it's going to stay at 68 cents. So my final amount here is $563.68. So therefore, Sebastian should have, so I'm going to say Sebastian will have $563.68. Okay, our next question is a little bit wordier. It says Jennifer needs to borrow $10,000 and will not be able to pay it back for 5 years. A local bank offers an interest rate of 4.38% per annum, compounded daily. Her parents are willing to offer the same interest rate, but compounded quarterly instead. How much money will she save if she borrows the money from her parents? So if I just take a look quickly through the question, I notice she is borrowing $10,000. She's also not going to pay it back for 5 years. She's being offered a rate of 4.38% per year, and it's being compounded daily if she goes through the bank. And if she goes through her parents, it's the same rate, but it's being done quarterly instead. And I want to know how much money will she save, which tells me it should hopefully be cheaper if she borrows the money from her parents than if she borrows the money from the bank. So what we're going to do here are two separate calculations, one for the bank and one for her parents. Now the first thing we should always do is try to figure out what formula we want to use here. And since I see that word compounded, that does tell me that I'm going to be using the compound interest formula. So that's A equals P times 1 plus I to the N. So I am going to list A, P, I, N for the bank. And I'm also going to list the same thing for the parents. So for the bank, that $10,000 is the principal, the amount that she's borrowing. She's not paying it back for 5 years, so that's going to go in for my N. There's an interest rate of 4.38%. That's going to go in for I. But it's being compounded daily. So what that means is we need to take the interest rate, we need to break it up into even amounts. We need 365 of them. And we always, always, always divide by 100. Now, if I'm dividing this one by 365, my N, we're doing it for 5 years, but we're doing it 365 times every year. So we're going to multiply 5 by 365. And then I'm just going to calculate. So 4.38 divided by 365 divided by 100 is 0.00012. And then 5 times 365 is 1825. Now, it's a given if it's 5 years, there has to be at least one leap year in there. We could add on a day, but it's possible there could have been 2 extra leap years. So what we tend to do is ignore the leap years altogether, just to keep it simple. But if you really wanted to, you could add in at least 1 extra year, because we know there would be 1 every 4, so we know there's at least 1 in there. And then what I'm going to do is take our formula and calculate. Just slide that up a little bit. So our formula here is A equals P times 1 plus I to the power of N. I don't know A. I know that P is 10,000. 1 is a 1. I is 0.001, oh, I missed a 0, 1, 2, to the power of 1,825. Now, I could do the adding in the bracket, or really, I can just work this out on my calculator. So if I use brackets, I should be fine. So 10,000 times bracket, and then 1 plus 0.00012, close bracket, to the power of 1825. And I end up with $12,448.15. So when you're trying to figure out whether you think your number is reasonable or not, she's starting at $10,000, she's ending at $12,000. So if she started at 10 and was finishing at 200,000, I'd be concerned. but 12,000 isn't really that bad in comparison. If we take a look at the parents, the only thing different about the parents is how often they're calculating their interest. So we're still borrowing, or she's still borrowing $10,000. That hasn't changed. The interest rate is still 4.38%, and the number of years is still 5. But instead of doing it 365 times a year, we're now only doing it 4. So we take our interest rate and we divide by 4. That's what quarterly means. And we always divide by 100. And then with our 5, we're doing it 4 times a year for 5 years. So we're going to multiply that 5 by 4. So 5 times 4 is 20. 4.38 divided by 4 divided by 100 is 0.01095. And then we're just going to take our formula, substitute our values in, and see what we end up with. So I'm using the same formula, A equals P times 1 plus I to the power of N. I don't know A. P is still 10,000. 1 is still a 1. I in this case is 0.01095 to the power of N, which is 20. So once again, I'm going to use my calculator to do that work for me. So 10,000 times bracket 1 plus 0.01095 close bracket to the power of 20. And I end up with $12,433.50. So the question asked, how much was she going to save? So if she was going through the bank, it's $12,448.15. If she goes through her parents, it's $12,433.50. So there's not a huge difference here, but there is a little. So I'm going to subtract. I'm going to take the amount the bank would charge her and the amount that her parents would charge her and subtract. So 12,448.15 divided by, subtract, sorry about that, 12,433.50 gives us a difference of $14.65. So she would save a huge $14.65. And that's it for our lesson. You should try your Check Your Understanding page before you call it a night. Bye.